Very good afternoon, guys. So in yesterday's class, we solved few problems based on average speed, and we discussed about velocity also, in fact, yesterday, and different types of velocity also called uniform velocity, non-uniform velocity, and instantaneous velocity, and average velocity. These are all we discussed yesterday. And yesterday, one more important point we discussed. In case of a straight line motion, the distance and displacement is the same in case of a straight line motion. Now, I would like to discuss about acceleration, which is very, very important. Acceleration. So, what do you mean by this acceleration? So, in our vehicles, either you go with a two-wheeler or four-wheeler, we have an accelerator. What is the functioning of that accelerator? That accelerator will always increases what? Increases its speed. So whenever the speed of a vehicle or whenever the velocity of a vehicle is increasing with respect to a time, then we can say that a body is moving or the vehicle is moving with certain acceleration. The word acceleration indicates that there will be an increment in its speed or there will be an increment in its velocity with respect to a time. That's why the rate of change of velocity is called as acceleration. The rate of change of velocity is called as acceleration. So acceleration is nothing but, as we discussed in previous classes, whenever the statement starts with rate, that is nothing but it is with respect to a time. So I will write acceleration as now change in velocity divided by time. Change in velocity divided by time will give the acceleration. Acceleration is equal to change in velocity by time. So for example, a body initially moving with an initial velocity u. U is nothing but the initial velocity. Initial velocity does not mean that it is the starting velocity. Initial velocity does not mean that it is the starting velocity. Why? Because every body will start its motion from rest only. That's why initial velocity is not nothing but it is a starting velocity. So for example, somewhere the body starts its motion, somewhere it is coming. So once it reaches to the point A, my observation starts on that body. So I am observing the body from the position A. So at the position A, what will be its velocity? That velocity only we consider as an initial velocity. So initial velocity is not a starting velocity. Initial velocity is the velocity at which we start to observe the body. So somewhere here a body is coming. We don't know from where it is coming. We least bother also from where it is coming. But my observation starts at the point A. At that point A, what will be the velocity of the body? That velocity will be considered as an initial velocity. So after some time, very good, it reaches to the point B. So the velocity at the point B, we call it as the final velocity. So generally the final velocity will be represented with V. Initial velocity will be represented with U. So my observation on the body only from A to B, that's all. So A is an initial point of my observation. B is the final point of my observation. So the velocity at the initial point, we call it as an initial velocity. The velocity at the final point, we call it as a final velocity. It takes a time of t seconds. It takes a time of t seconds. Now, acceleration is nothing but change in velocity by time. Now, acceleration will be always denoted with the symbol small a. Change in velocity. Change in velocity is nothing but final velocity minus initial velocity. So, a is equal to final velocity minus initial velocity divided by time. So from here I will write with your permission, A is equal to final velocity will be represented with V, initial velocity will be represented with U, time will be represented with T. So A is equal to V minus U by T is the formula to find out the acceleration. And again I am insisting you, the word acceleration will be used if and only if the velocity of a body is increases. Okay. Now what is its unit? What is its unit? In SI system, the unit of velocity is meters per second. What is the unit of final velocity? Meter per second. What is the unit of initial velocity? Which is also meter per second. Why? Because here it is a final velocity or initial velocity. Basically it is a velocity. Ashte. So, which is meter per second. The unit of change in velocity is meter per second divided by time. The unit of time is second. So the unit of acceleration will be meter per second square. The unit of acceleration in SI system, meter per second square. Similarly, in the case of CGS system, the unit of distance is a centimeter. Instead of meter, we have to go with a centimeter. Second is the same. Whatever the system you take, either you go with an FPS system, or you go with a CGS system, or you go with an MKS system, or you go with an SI system, the unit of time is second only. That's why centimeter per second square is the unit of acceleration in CGS system. So basically acceleration is nothing but change in velocity by time. Since as we know the velocity is a vector quantity, you know what is a vector quantity, which will have both magnitude and direction. Since the velocity is a vector quantity, the acceleration will be also vector quantity. The acceleration will be also vector quantity. So acceleration is nothing but the rate of change of velocity, which is nothing but change in velocity by time. If u is the initial velocity and the velocity of a body becomes v after traveling a time t, then acceleration is nothing but change in velocity by time, whereas change in velocity is nothing but final velocity minus initial velocity divided by time, which is equal to v minus u by t. So the unit of acceleration in SI system is meter per second square, whereas in CGS system centimeter per second square, and acceleration is a vector quantity. Okay. whenever there is a decrement in the acceleration, whenever there is a decrement in the velocity, if the velocity decreases, when the velocity decreases is nothing but if the initial velocity is greater than the final velocity. If the initial velocity is greater than the final velocity, note point. If initial velocity is greater than the final velocity, we'll use the word acceleration if and only if final velocity is greater than the initial velocity. If initial velocity is greater than the final velocity, then obviously the acceleration will get a negative value. Is it right? How will get the negative value? Since u is greater than v, since u is greater than v, will get the negative value. So the acceleration will becomes negative when if the initial velocity is greater than the final velocity. That negative acceleration, we call it as retardation. Retardation is nothing but the negative acceleration. Retardation is nothing but the negative acceleration. Whenever the acceleration is negative, when the acceleration will be negative, if there is a decrement in its velocity. When the velocity of any body or a vehicle will decreases once you apply a brake. If you apply a brake, definitely the velocity of a body will keep on decreases. So we are going to get the acceleration will be negative because we don't have any separate formula to find out the retardation. Okay. So we'll have only one formula to find out acceleration. So by using A is equal to V minus U by T, if you get positive value, we called acceleration. If you get a negative value, we called retardation. Okay. Note down one simple problem based on this formula. A body is moving with some initial velocity or is moving with an initial velocity 15 meters per second. 15 meters per second. After 2 seconds, its velocity becomes 5 meters per second. After 2 seconds, its velocity becomes 5 meters per second. Then, what is the retardation? So here he is not asking acceleration. He is asking retardation. Be careful. Okay. So in that problem, if you go through that problem, what's the data he gave? Initially, a body is moving with 15 meters per second. So initial velocity is 15 meters per second. That is u is equal to 15 meters per second. Its velocity becomes, that is nothing but the final velocity, which is represented with v, is 5 meters per second in a time of 2 seconds. So that is the data what he gave. U is equal to 15 meters per second, v is equal to 5 meters per second, and t is equal to 2 seconds. He is asking us to find the retardation. What I said, there is no separate formula to find out the retardation. So as usual, we'll go with an acceleration only initially. So the formula to find out an acceleration, A is equal to V minus U by T. Whereas V is equal to 5, U is equal to 15, T is equal to 2. So which is equal to minus 5 minus 15 minus 10 by 2 minus 5 minus 5 meters per second will be the acceleration. Acceleration is minus 5 meters per second square. But he is asking us to find retardation, not acceleration. Then as we know, retardation is equal to negative acceleration. Retardation is nothing but the negative acceleration. Then minus acceleration value, how much we got? Minus 5. So minus into minus plus. So the answer is plus 5 meters per second square will be the retardation. If he asks us to find acceleration, the answer will be minus 5. Since he is asking here the retardation, the answer will be plus 5. Okay? If he asks us to find the retardation, it will be, the answer will be in plus, because retardation is nothing but the negative acceleration. So this is about acceleration. Next, uniform acceleration. Side heading. Uniform acceleration. Uniform acceleration. So the acceleration is uniform. When the acceleration will be uniform, uniform is nothing but constant. When the acceleration will be constant, the ratio of V minus U and T should be constant. When it will be constant, if V minus U value as a constant, T value as a constant. If these two are constant values, obviously the ratio will be also constant. That is nothing but, for example, the velocity of a body changes from 5 to 10 meters per second in a time of 2 seconds. Okay. Then after 10 to 15 in the same time of 2 seconds. The velocity of a body changing from 5 to 10 in 2 seconds. Then after 10 to 15 in the same 2 seconds. If I go with the AB, what is an acceleration here? Acceleration is nothing but final minus initial. That is nothing but 10 minus 5 divided by T, 2 seconds. So 5 by 2, which is equal to 2.5 meter per second square, will be the acceleration between A and B. In the same manner, if I go with BC, what is an acceleration here? 15 minus 10 divided by 2. 15 minus 10 is nothing but 5. 5 by 2, which is equal to 2.5 meters per second square. So between A and B, acceleration is 2.5. Between B and C also, the acceleration is 2.5. Then I can say that a body is moving with uniform acceleration. Then how you are going to define it? If the velocity of a body changes equally, here between A and B, what is the change in velocity? 5. Between B and C also, change in velocity is 5. So here, the velocity of a body changes equally in equal intervals of time. Okay, then we can say that a body is moving with a uniform acceleration. Understood? If the velocity of a body changes equally in equal intervals of time, however small those intervals may be. So, while in previous definitions I discussed what is meant by however small those intervals. It is not necessary to have only 2 seconds and 2 seconds. If it is 0.2, whatever it may be, it is a smaller value you take. Okay? So note down, put a heading, uniform acceleration. If the velocity of a body changes equally, if the velocity of a body changes equally in equal intervals of time, if the velocity of a body changes equally in equal intervals of time, however small those intervals may be, then the body is said to be moving with uniform acceleration. Said to be moving with uniform acceleration. So whenever a body is moving with uniform acceleration, is nothing but change in velocity with respect to time is uniform. Change in velocity with respect to time is uniform. Okay. Next, non-uniform acceleration. Non-uniform acceleration. If the velocity of a body changes unequally in equal intervals of time, or equally in unequal intervals of time, or equally in unequal intervals of time, however small those intervals may be, then the body is said to be moving with non-uniform acceleration. Then the body is said to be moving with non-uniform acceleration. You just see like this. What is non-uniform acceleration? If the velocity of a body changes unequally. So here, for example, if I take it as a 25. Between A and B, what is the change in velocity? 5. Between B and C, what is the change in velocity? 15. Now, the velocity of a body changes unequally in equal intervals of time, 2 and 2 only. Then what will be the acceleration now? Between A and B, the change in velocity is 5. 5 by 2, 2.5. Between B and C, the change in velocity is 15. 15 by 2, which is equal to 7.5 meters per second square. So now what we can conclude? The velocity of a body changes unequally in unequal intervals of time. In such a case, we are getting the different accelerations. That is nothing but the acceleration is not uniform here. That's why it is called as a non-uniform acceleration. In the same manner, we can say, if the velocity of a body changes equally in unequal intervals of time. Here, what is the change in velocity between A and B? 5. Between B and C is also 5. But the times are different. Here 2 seconds, here 20 seconds. So between A and B, what is an acceleration? 5 by 2, 2.5. Between B and C, what is change in velocity? 5. How much time? 20 seconds, which is equal to 0.25. 0.25 meters per second square. So here is also the acceleration is not same. So we can call it as a non-uniform acceleration. If the velocity of a body changes equally in unequal intervals of time or unequally in equal intervals of time, however small, then we can say that a body is moving with non-uniform acceleration. Next, third one, instantaneous acceleration. Instantaneous acceleration. The acceleration of a body, at certain instant. The acceleration of a body at certain instant is called as instantaneous acceleration. Is called as instantaneous acceleration. Okay. Next, you put a heading, equations of motion. Equations of motion. Equations of motion. Since from childhood, in physics, you may come across these formulas. What are those? First one, V is equal to U plus AT. These formulas are very familiar. Second one is S is equal to ut plus half at square. Third one is v square minus 2u square is equal to 2as. Like that, many other formulas are also there. Then, so these formulas everybody may know, everybody of you, but very few know when to use these formulas, where to use these formulas, how to use these formulas, right? When to use this formula, when we are going to use the second formula, when we are going to take the help of the third formula, these very few knows. That's why I would like to derive each and every formula so that you will get a knowledge or you will get an idea when to use, how to use, where to use those formulas. Okay? But one fundamental thing you need to remember, whatever the formula we use, these out of these three, whatever the formula we use, those formulas should be used, listen carefully, those formulas should be used if and only if when a body is moving with uniform acceleration. Whenever a body is moving with uniform acceleration, then only we can make use of these formulas. If a body is not moving with uniform acceleration, if a body is not moving with uniform acceleration, andre non-uniform acceleration ಇಂದ ಹೋಗ್ತಾ ಇದ್ರೆ, then we cannot make use of these formulas. Then what are the procedure we need to adopt? So that also we'll discuss later. Okay, basically you have to remember these formulas should be used if and only if a body is moving with uniform acceleration. So that thing should be in our mind. Blindly we should not take these formulas. So the basic condition is a body should be moved with uniform acceleration. Okay. So first one, derive v is equal to u plus at. Derive v is equal to u plus at. What is v there? Final velocity. What is u there? Initial velocity. What is small a? Acceleration. What is t? Time. Okay, note down. Consider a body is moving with, consider a body is moving with initial velocity u and uniform acceleration a. And uniform acceleration a. Small a, full stop. Its velocity becomes v. Its velocity becomes v after time t seconds. Its velocity becomes v after time t seconds. Andre ಏನಪ್ಪ ಇಲ್ಲಿ? What we are doing? We considered a body. Initially it is moving with u and uniform acceleration a. Very good. Uniform acceleration a. Its velocity becomes its velocity becomes v in a time of t seconds. Andre ಏನಪ್ಪ ಇಲ್ಲಿ? We know the initial velocity, we know the acceleration, and we know the time also. So here we are going to find the final velocity v. Then as we know, acceleration is equal to change in velocity by time, that is nothing but final velocity minus initial velocity by time, final velocity minus initial velocity by time, which is v minus u by t. If you cross multiply, at is equal to v minus u. From here, with your permission, I will write v is equal to, if I bring minus u this side, it will be plus u. V is equal to u plus at. V is equal to u plus at. So like that we got this formula. V is equal to u plus at on the formula. Enga bantu? Inga bantu. So again I am saying this formula should be used if and only if a body is moving with uniform acceleration ashte. If it is moving with non-uniform acceleration, we should not make use of these kind of formulas. Okay? Based on this formula, one simple problem. A body starts from rest. A body starts from rest and moving with uniform acceleration of 4 meters per second square and moving with uniform acceleration of 4 meters per second square. Full stop. Find its velocity. Find its velocity. Find its velocity after 10 seconds. After 10 seconds. So here, what he mentioned, a body starts from rest. Rest is nothing but its initial velocity is 0. A body starts from rest. So u is equal to 0. And it is moving with uniform acceleration of 4 meters per second square. Uniform acceleration of 4 meters per second square. Now what will be its velocity? Very good. At a time of 10 seconds. It is as simple as time of 10 seconds. So we know the u value, we know the a value, we know the t value. He is asking us to find the v value. And moreover, the body is moving with the uniform acceleration a. So happily we can make use of this beautiful formula, v is equal to u plus at. V is equal to u plus at, where u is equal to 0, a is equal to 4, t is equal to 10. So 4 into 10 will be 40. So v is equal to 40 meters per second. Sometimes he will give the v value, a value, t value. Intelligently he will ask us to find the u value. Same formula. By knowing 3 parameters, one unknown parameter easily we can find. But as for PUC is concerned, the calculators are allowed. Calculators. That too simple calculators. No scientific calculators. Simple calculators are allowed. Like in that calculator, multiplication, addition, subtraction, division, square root, percentage, like that small mathematical operations we can take the help. But one pity is that for objective, that is competitive exams, it might be a KSET, it might be a JEE mains, it might be a NEET examination for medical aspirants, the calculators are not allowed. For PUC, calculators are allowed. For objective, for competitive exams, calculators are not allowed. That's why my suggestion is, though the calculators are allowed, you don't make use of calculators for simple calculations. For simple calculations, you don't use. Okay? Once you are addicted to use the calculators, definitely you will face a lot of problem while in objective examinations. In one bad situation, if I ask, what is 2 into 2? That also you will take the help of calculator. So that's why my suggestion is not to addict or not to use the calculators. If you are in original class, definitely I will restrict, I will observe. But whereas it is a virtual classes, so you have to take care, because I don't know either you are using calculators or not. My suggestion is not to use calculators. So tomorrow remaining derivations will derive and we'll solve the problems based on that also.